you will end up with 24.0625 plus 25.25 plus 26.5625 plus 28. Which gives you a roundabout estimated value of 25.97, which is your upper sum. Okay. So if you got this function, I'll bring it back up in a second, and you divide it into 4 rectangles with our delta x, we already figured out to be 25 between 2 and 3. If you added all 4 of those rectangles together, you'd end up with 25.97 as your upper sum. If you did the lower sum, it'll be less than that. All right, so any questions on that one? All right, I'll leave that up for a little bit, and then I'll do a lower sum example. All right. Okay, so let's say for this example, again, if we're using 4 subintervals, find the lower sum. For f of x equals 16 plus 4x squared on the interval from 1 to 2, and round to the nearest hundredth. So again, first thing you want to do, which is by far the easiest, is find your delta x. Okay, so you know that this is your A, and this is your B. And you have 4 subintervals, so your n is going to equal 4. Okay, so n is equal to 4, which means that your delta x, which is b minus a over n, is going to equal 2 minus 1 over 4, which again is 1/2, well, not 1/2, 1/4. Sorry about that. Which is 0.25 again, just coincidentally. Okay, so we know our delta x is 0.25. Okay, so that means our subintervals will be, still going to start at 1, but we're only going to go up 0.25. So from 1 to 1.25. Then we're going to start at 1.25 and going to go to 1.5. Then from 1.5, we're going to go to 1.75. Then 1.75, we're going to go to 2. So all of these are delta x apart. Okay, so if they said 2 subintervals, we would have gone from 1 to 1.5 and 1.5 to 2. So the number of subintervals just means the distance of each interval. Okay, so again, we can see that the function increases between 1 and 2. So you have 16 plus 4 and 16 plus 4 times 4. So it would increase between 1 and 2. So the function increases over the interval 1 to 2. So the lower sum uses the left endpoints. Okay, so if we were to graph this, just to give you a visual, make that a little bit bigger. Okay, when x is equal to 0, y is equal to, where is it, 16, and that's between 1 and 2. Okay, so it's between there. So for our lower sum, our left endpoint is going to touch. Okay, and because our left endpoint is the first one that's going to touch the graph, let me clean that up a little bit. Remember, this is our x0, that's our x1, that's our x2, that's our x3, and this is our x4. Our x4, which is equal to 2. I can go ahead and erase that 2 out the way. Okay. So since the left endpoint is the first one to touch the graph, our sum, and I'll write the equals 0 to 3. Because remember, we're only going to go from the left endpoints. So this is x0, x1, x2, and x3. Those are all the points that are actually touching the graph. So that's why we're not counting x4, because it's not touching the graph for that one. On the last one, it was actually touching the 4. Does that make sense? Okay. So here we're going to go from x0 to x3 of f of ci of delta xi. Well, you don't really need the xi because they're all the same delta x, so you don't have to change that up.
They will always be that, right?
Oh yeah, for these, yep, they'll all be the same subinterval. Okay, so that's going to equal the sum from I equals 0 to 3. Our f of ci is just our function. So 16 plus 4 of x of I. Oh, I'm getting ready to square the whole thing again. The xi is squared. Times your delta xi for all of them, they're 0.25. Okay. So just like we did before, we can just bring the 0.25 right out to the front. Or you can leave it for each term, completely up to you. Okay, so if we plug in 0, our x of 0 is equal to 1. So that's 16 plus 4 times 1 squared plus 16 plus 4 times our x1, which is 1.25 squared plus our x 0, 1, 2 1.5 squared, and our x3, oops, see if I have enough room, I should, 16 plus 4 times 1.75 squared. There we go. Okay, so again, that's our x0, x1, x2, and our x3. Okay. So if we actually calculated these, this would be 20 plus 22.25 plus 25 plus 28.25. Okay. Which if you add them up and everything, it would give you 23.88, which is your lower sum. So any questions on that one?
So when
Yes.
you're doing your lower sum,
Mhm.
you just always leave off the last endpoint?
It depends on if it's increasing or decreasing.
Okay.
Because I actually do have another example of one that is decreasing.
Alright, so if it's decreasing, you would
Mhm.
include it, and then if it's,
But then you'd disclude the first endpoint.
Yep, it all depends on if they're asking for the upper or lower sum.
what's that?
It all depends on if they're asking for the upper or lower
Yeah.
sum. So if they're asking for the, in this case, the lower sum, and it's increasing, then you use the left endpoints. But if they were asking for the lower sum and it was decreasing, on that one, then you'd use the right endpoints.
Yeah, okay. And then the upper sum
Yep.
is just the opposite.
Yep, just the opposite. Yep, trying to see if we have enough time. But we want to still write in. Okay. I'll try to go through this one pretty quick. Okay, so what is the upper sum for f of x, which equals 14 minus 3x squared on the interval, closed interval, 1 to 2. Using 4 subintervals. I think most of the problems have 4 subintervals. And again, round to the nearest hundredths. Okay, so we know 4 subintervals, so our n is going to equal 4. Remember, this is our A, and this is our B. Okay, so that means your n is equal to 4, so your delta x is going to equal, which is b minus a over n, will give us 2 minus 1 over 4, which is 1/4, which is again 0.25. Okay, so that means your subintervals will be, again, we're going to start at 1, but we're only going to go up 0.25. So 1 to 1.25. Then we're going to start at 1.25 and go up another 0.25. Then we're going to start at 1.5 and go up another 0.25. Then we're going to start at 1.75 and go up another 0.25, which is R2. Okay. So here we see the function actually decreases between 1 and 2. So the function decreases between x equals 1 and x equals 2. So the upper sum would actually use the left endpoints. Okay, so to give that kind of a quick visual. Okay, so we know that when x equals 0, y is equal to 14. So it kind of looks like this between 1 and 2. No, 2 is probably a little further to the left. I'll move this over so I have room to write my okay, so this is our x0, which is 1. So if we're looking for the upper sum, bring that up a little bit, make that as straight as possible. Okay. Remember, our upper sum goes over the graph. So it goes up, then it goes to the right, to the right, to the right. Well, I did have enough room. To the right, I'll just bring my 2 over here. Okay, so if you notice, all your left endpoints are touching the graph. That means this is your x1, that's your x2, and that's your x3. And 2 is your x4. Okay, so that means since our left endpoint touches first, we're going to start at x0. Now, if our right endpoint touched first, we'd start at x1. So that means our sum from I equals 0 to 3 of f of c sub I delta xi will equal the sum from I equals 0 to 3. That's just our function. 14 minus 3 times x of I squared. And our delta x, again, is 0.25. Okay. So from there, like I said, we can get our 0.25 and bring that out to the front. Okay. Our x0 is 1. So it had 14 minus 3 times 1 squared. Our x1 is 1.25. So it's 14 minus 3 times 1.25 squared. Uh-oh, that should be plus. Sorry about that. Plus 14 minus 3 times 1.5 squared. Plus 14, minus 3 times 1.75 squared. Okay, so again, this is our x0, that's our x1, that's our x2, and that's our x3. Okay, so that's going to equal 0.25 times 11 plus 9.3125 plus 7.25 plus 4.8125, which gives us 8.09 as our upper sum. Does that make sense? Hopefully you can see kind of the pattern of how it's figured out.
So like the I equals 0 for this one, because our first point it touched was x0.
Yep, that's it.
So what if, and you would never start at like x0, you couldn't call that x1? And
Nope.
it'd be x1, x2, x3, x4, x5?
Nope, because remember on the definition, let me see if I can. Yep, your x0 is equal to a. Yep, where is it?
Oh.
Yep, your a is equal to x0. So whatever your a is here, that's always going to be your x0.
All right.
Yep. All right. Any other questions on this one? All right, and we will stop there.